All right, we're going to get into the unit that deals with linear functions and graphing. You graphed linear functions last year, but it was kind of rush because toward the end of the year. So we're going to kind of recap it, and then we'll go into some Algebra 1 material after we do a little recall or recap, okay? All right, so we're going to talk about linear relations. Linear relations are relations, and we should know from the last unit. I know it was Christmas break, so y'all probably don't remember. But relations are just sets of ordered pairs, guys. They're points. All right? So there are points that lie along a straight line when graphed. So if you graph them, they make a straight line, hence the word linear. And in the word linear, you see L-I-N-E, line. Okay? So if your points or your set of ordered pairs, which is your relation, makes a straight line, it's called a linear graph or a linear relation. And here is an example. There you go. So you should see several points on this line. I'm going to highlight them. That's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Actually, there are more than 9 points that are on that line. You just don't see them. They're not like distinct. In other words, you can't name them. So if that point's on the line, but that's over 1, 2, 3, 4, 5, 6, 7. It's a point between 7 and 8, and this is between 7 and 8. Of course, we wouldn't put between 7 and 8, but we put 7 point something. That's probably better. It's 7 point something, guys. And then the y value lines up about right here. I would say it's like 0.5. It's in between 0 and 1 on the y-axis, so it's 0 point, I don't know, something. But that's a point that's also on the line. This point lies on the line. This point lies on the line. This one, anything on that line is a point. Okay, it's an infinite amount of points on that line or ordered pairs, although you don't see them. Now, these that I have in red, they're what we call distinct points, which you can name. Like I know that's 0, and then 1, 2, 3, 4, 5, 6, 7, 8. That's the point 0, 8. This one right here is over 1, 2, 3, and up 1, 2, 3, 4, 5, 3, 5. Let me write that a little better. But all the points lie on the line. Those you see or you can name, and those you can't name. They lie on the line. And it makes a linear relation. All right, let's keep it moving. Linear relations can be represented a number of ways. One is with a graph, as you have seen here. Okay, that's with a graph. A table, we did that in the last unit when we dealt with functions. You had a table of values. Your table looks like this. XY table where you have, maybe some numbers, some ordered pairs. Something like that. That's a table of values. Set of ordered pairs, your set will look like this, for example. You know what? Let me put it in set notation. And all this is from the last unit. Or in a mapping, you all know a mapping is just two ovals. And if I wanted to map this relation right here, then I could map 1 to -3, 0 to -4, and so forth, okay? And it can also be represented as an equation. So linear relations can be represented 1, 2, 3, 4, 5 ways, guys. It can be represented 5 ways. All right, and let me give you an example of the equation. 2x plus 4y equals to 8 is a linear equation. Y equals to 2/3 x is a linear equation. So let me go a little more in depth into what's linear and what's not, because some of you can be like, well, how do I know which one is linear and which one isn't linear? Just I need some more sticky back tape for that. But don't put it back up. I get it. Because it's gonna fall again.
Oh, okay. Were you talking to me or you on the phone?
I'm making a video.
I'm sorry.
It's okay. They're probably used to me doing this anyway. All right, but I'm gonna go ahead and we'll take a look at how do you decide whether an equation is linear. Linear equations can be written in what we call standard form. This is standard form, what I have in red. AX plus BY equals to C. That's standard form. Where you got X and Y on the same side, and then C is some constant, like it's some number by itself. Or it can be written in what we call slope intercept form. It's in blue, which is Y equals MX plus B form or Y equals MX form. So you need to remember those two things, okay? You need to remember standard form, and you need to remember slope intercept form. Okay, those are the two ways you're going to see linear equations written. All right, so let me talk a little bit about standard form. So standard form, AX plus BY equals to C. So let's talk about what these letters mean. A and B are what we call coefficients of X and Y. Coefficients are the numbers that are stuck to the variable. So it means you're going to keep your X and your Y. A and B will be coefficients, so just numbers stuck to them, okay? And C is some constant, some regular number. A constant is a regular number. You might want to put that in your notes. You pause the video and write constant is a regular number. The variables X and Y represent the items of the things being discussed. So I'm going to give you a real life example, okay? And keep in mind, we're talking about AX plus BY equals to C, which is standard form. So this is what we're on. We're going to talk about what A represents, what B represents, what X represents, what Y represents, and what C represents, guys. So like you won't be lost. All right, so a real life example. So this stuff just won't be some random variables to you. Samantha purchased 2 jackets and 3 shirts. Okay. So remember when I said A and B are coefficients of X and Y, and if you go back up here, it says they're coefficients, but then you got to look at X and Y. X and Y represent the items of the things being discussed. So the things being discussed are jackets and shirts. That's your X and your Y. We're going to look at that first. And A and B are going to be coefficients, okay? What am I talking about? So the things that I'm talking about, that I'm discussing, I'm talking about some jackets and some shirts. So my X and Y are jackets and shirts. But now coefficients are numbers that sit in front of them. So your coefficients, your A, there's your A, it's attached to X, and your B is attached to Y. A and B are going to be coefficients, the little numbers that sit in front of them. So what are we talking about as far as X? Well, we know X is the jackets. And we know Y is just the shirts. We're talking about shirts. Now, you could have let Y be jackets and X be shirts. I don't care. But we normally go X and then Y. Okay. So what do you think A is going to be? Well, A is the number of jackets. So A is the number 2. Remember, A and B are numbers, what we call coefficients. X and Y are things that you're talking about. The things you see. Okay, the things you're discussing. A and B are coefficients or just regular or numbers that sit in front of variables. Numbers attached to variables. They gotta have some relation to the variable. So what has a relation to jackets? 2. What has a relation to shirts? That would be 3. So B is not B. B is 3, guys. Sorry. B is 3. That's the number, okay? So automatically I know 2 jackets and 3 shirts, and we're talking about standard form. Standard form is AX plus BY equals to C. Now, what's this C going to be? I know 2 is attaching to X because it's 2 jackets and X is jackets, and 3 is attaching to Y because Y is shirts and it's 3 shirts. But what is C? So if you keep reading, it says the total cost was $284.99. That's your C. That's that number. So basically, the 2 jackets right here plus the 3 shirts cost a total of $284.99. I didn't mean to put that decimal right there. Take that out. So the equation that you can write in AX plus BY equals to C form would be 2X plus 3Y equals to 284.99. That's an equation you can write. And this is linear. Okay? It's in the form AX plus BY equals to C. So it's a linear equation. And I know what X and Y are, and I know A and B are the numbers associated with X. A and B are the numbers associated with X and with Y. And C is just that number that it totals up to be. Okay? Let's take a look at the other way you can have a linear equation, the other form you can have a linear equation written in. So it can be written in what we call slope-intercept form, which is y equals mx plus b. Okay? So I'm going to tell you what each of these letters represent again. So M, I hope everybody knows by now, M is slope, or what we call rate of change. I don't know if we did that in the last unit. We didn't, but we did it in 7th grade, so you may not remember. Okay? M is slope or rate of change. Last year, I may have called it unit rate, but it's all the same thing. All right, what does step B represent? B is your y-intercept or your initial value. Initial meaning where something starts at. Like, what did you do initially? What did you do to begin with? That's all that means, initial value. What was the beginning? And then the variables X and Y represent your independent and dependent variables. Now, I know you know independent and dependent because we did it in the last unit. Remember, I told you your independent thing has to happen before your dependent thing. So the independent will happen first, and then the dependent will happen. All right, so, or you can write it what we call a dependent statement. All right, so let's take a look at this real life example so you can kind of put the letters with something that makes sense. It says Daniel finds a job that pays him 15% commission on all his sales and a weekly salary of $500. So you're going to write a dependent statement for that situation because I need to identify my X and my Y. So I should know that Daniel's salary depends on the amount of sales. He doesn't get paid, guys, unless he sells something. So you got to sell something first. So your sales is going to be your independent. But if I write a dependent statement, I'm going to put Daniel's salary depends on his amount of sales. So whatever amount he sells to get 15%, he gets 15% commission off of that. Now, what does 15% commission mean? 15% commission means he gets or earns 15 cents on every dollar he sells. Okay? So if he sells $1 worth of merchandise, he gets to keep 15 cents and the company gets 85. All right. Or if he sells $2 worth of merchandise, he gets to keep 30 cents or 15 cents twice. Okay. And then the company gets to keep 85 cents twice. If he sells $3 worth of merchandise, he gets to keep 45 cents. 15 cents for the first dollar, 15 cents for the second dollar, and 15 cents for the third dollar. So that's what 15 cents commission means. Whatever he sells, he gets to keep 15 cents of it. Okay, 15 cents for every dollar. But his pay depends on the amount of sales. Okay, so we know the salary is dependent then. So your salary is your dependent variable, it's your Y. And then the amount of sales is your X, or your independent variable. Now keep in mind when we did AX plus BY equals to C form, when we did this, guys, you don't have to write this down, but listen. X and Y were just the things we were talking about, like jackets and shirts, okay? But when you get down here and you're talking about slope intercept form, your X and Y will represent your independent and dependent variable. All right, M. So let me tell you what M represents. It says slope or rate of change. That's what it says up here in purple, slope or rate of change. So I want you to think about it this way. Find a number that is a constant or a set rate, okay? Some set rate. Well, what's set in Daniel's pay? Okay, I know it's $500. That's set, but it's not a rate. It's not something that's happening per something else, okay? So 15 cents is happening for every dollar, or 15. Your rate is 15 cents per $1. That's a rate, guys. So the 15 cents is your rate. That's your set rate. That's what he's going to get paid for every dollar worth of merchandise he sells. So our M would be 15 cents. Don't put 15% because when we write a percent in terms of a number, we write a percent as in decimal form. So 15% in decimal form is 0.15. So that's our constant rate of change, okay? Or our set rate. I hope that makes sense. If it doesn't, pause the video, let me know. Again, when you are finding M, you're looking for something that's constant, that is unwavering, it's not changing, but it's a rate, guys. So it's happening because of something else. All right? But it's constantly happening. Sell $1, get 15 cents. Sell another dollar, get another 15 cents. Sell another dollar, get another 15 cents. That is a set rate of change, all right? All right, B, I need you to find the initial amount he's going to make even with 0 sales. So if Daniel doesn't sell $1 worth of merchandise, not even a penny worth of merchandise. So Daniel, you're not selling anything. You're a pitiful salesman, Daniel. No, not for real, okay? But in this example, suppose you don't sell anything, Daniel, okay? Class, y'all listening? If Daniel doesn't sell $1 or a penny, nothing, he sells no merchandise, is he guaranteed any money? Sure. Okay. What is Daniel guaranteed even if he doesn't sell a thing? Well, he gets a weekly salary of $500. So 500 is the B. Okay. That's even with 0 sales. Keep in mind, I'm underlining 0. So if he doesn't sell a thing, he'll still make $500. At least you get to bring home $500 if you're not a good salesman, Daniel. All right, so you always think about your initial amount or the variable B in this, y equals mx plus b. You always think about this as being, what do you start with anyway, regardless of what this is, even if that's 0, okay? What do you start with? You're going to start with $500, and you may not keep 500. You start with 500. Now, if you sell some stuff, you're going to end up with more than 500. You don't sell anything, you still got 500 because that's what you started with. All right, so I don't have this on the paper, but I want you to write equation for me right here. And we're going to write the equation in y equals mx plus b form. So y is our salary, okay? But we're not going to change it to anything. We're going to keep y and we're going to keep x. But I do want you to know what they mean. So when you write an equation in slope-intercept form, basically you're just going to be replacing m and b. And you'll be keeping y and x. So what is m? M is 15 cents. You keep your x and your y. I meant to do that in red, color code, because I'm keeping the x and the y. All right, plus what is your b? The initial amount was $500. So this is also what we call a linear relation. Okay? It has a slope and it has some initial value. And in order for it to be in what we call slope-intercept form, y must be on one side of the equation by itself. It has to be. Now, the other form we talked about again was AX plus BY equals to C form, and that's called standard form. And if I go back, so I'm going back to the first page of the notes, guys. Going back up here. Right here. When it told you that an equation can be, a linear equation can look like this or that right there, okay? Trying to highlight it out. So this is in the form AX plus BY equals to C, where A is 2, B is 4, and C is 8. This is in the form Y equals MX, but there's no plus B. Remember I said it can be in the form Y equals MX plus B or Y equals MX without the B. It's really a B. It's just that here your B is 0. This is really plus 0. But in math, we don't normally write the 0. Okay, so instead of saying Y equals MX plus B form, we just write Y equals MX when we know B equals 0. Okay. Now, B is something other than 0. We got to use this form. But this is also linear, guys, because it's in the form Y equals MX. In this case, B would just be 0, but we don't put it, all right? All right, now, somebody's going to say, well, if I have something that looks a little different, so if you have this equation, guys, I'm going to write this down. Suppose you have 3y equals to, I don't know, we'll say 6x plus 9.
Pardon the interruption, teachers. I just wanted you to know that we're not going to have the faculty meeting today. We'll have it on Monday of next week. And at 3, you can leave for the day. Thank you.
All right. So this is not in AX plus BY equals C form, nor is it in Y equals MX plus B form or Y equals MX form, where B is 0. This doesn't have Y by itself, but if you have an equation that can be converted to this or to this form, or I say order one of these, Y equals MX plus B or Y equals MX form. If you have an equation that can be converted to one of those, it's linear. Like I can solve for Y. If it's a Y equals MX plus B form, you got to get Y by itself. So if we solve for Y, all we got to do is divide by 3. So we get Y equals to 2x plus 3. Well, this is Y equals to MX plus B form. So that's linear as well. So it doesn't have to originally appear in AX plus BY equals to C form, which again is standard form. And it doesn't have to appear in Y equals to MX plus B or Y equals to MX form, which is slope-intercept form. It just has to be able to be converted to one of those. Okay? If it can't be converted to one of those, it's not linear. Now I'm going to show you something else, guys. Oh, well, we'll talk about that later because you're going to have these. These are what we call special linear equations. But we'll talk about those later. We're not going to worry about those right now. All right, let's keep going. All right, we're going to talk about slope. And we're going to do slope from, we'll do, let's see. 4 types of slope. We'll do slope from a table. I think all I'm going to do is slope from a table today because I'm running out of time. All right, so let's go to slope. We're going to talk about slope because I tell you it's, if we write an equation in Y equals MX plus B form or Y equals MX form, that M is our slope. It represents our constant rate of change, okay? Some set rate of change. So it says slope can also be thought of as a constant rate of change between points on the graph, or what we call rise over run, guys. And you may remember that from last year in 7th grade. It may be coming back to you. So let's see. There are 4 types of slope. There's what we call a positive slope. And it will go upward from left to right. There's what we call a negative slope. and it will go, and this is from left to right, guys. A negative slope will go down from left to right, what we call decreasing. So on the left side, it'll be up, but then on the right side, it'll be going down. Then there's something called a zero slope. A zero slope neither goes up nor down. It's just flat. Zero slope. It's not, there's no incline. There's no positive, no negative direction. It's just flat, zero, like the floor. If you look at the floor, it's flat. The floor has a slope of 0, okay? And then there's something called an undefined slope. An undefined slope is like the wall. The wall, it's straight up. If you run your hand against the wall, it's straight up and down. That's an undefined slope, which means basically slope doesn't exist for it, all right? All right, those are your 4 types of slopes. So what we're going to do is learn how to calculate slope from a table. To calculate slope from a table, we're going to be using this formula or notation. This doesn't mean triangle y. It means change in y. So our change in our y value over our change in our x value. If you can calculate that, that means you can calculate slope. So I'm going to take a look. Remember, it's the change in y over the change in x. Okay, so I'm going to look at A. So I'm going to look at my y values first. So what am I doing to -4 to get to -2? Well, I'm adding 2. -4 plus 2 equals -2. Okay, so the change here is -2. But I have to look at the corresponding changes for the x's. So if I use, and I'm looking at these 2 points, I'm going to highlight the 2 points I'm going to use. Now, you can use any 2 points you want to. I don't care which 2. Just pick 2 in the table. And I'm going to show you it doesn't matter which 2. So what am I doing to get from -4 to 0? Well, to get from -4 to 0, I'm adding 4. -4 plus 4. Oh, I'm going up 4. So that change there is a +4, but that's going to represent your slope. We denote slope with an M, remember. So the slope here is -2/4, or in simplified form, it's -1/2. That's it. So if I were to graph these points, all 1, 2, 3, 4, 5 of them, and plot them, that line will be going down here. I know that because my slope is negative. It'll be going down from left to right. Now, I don't care what 2 points you use. So I'm going to show you. You don't have to write this down, but you can watch me. Suppose I didn't want to use those 2 points. Suppose I wanted to use these. Suppose I wanted to use this one and this one. I don't care. Just pick 2, okay? Pick 2 points and find the change in y over the change in x. I'll do this one in green. So the change in y. So what am I doing to -2 to get to 4? Well, I know I'm going up, so I'm adding something, not taking away. -2 plus 6, I'm going up 6. So the change in y is 6. Make sure you do y before x, okay? It's not like the alphabet where it's x and then y. Okay, x and y comes when you're graphing an ordered pair. You put your x coordinate, then your y coordinate. But when you're doing slope, it's just the opposite of an ordered pair or graphing an ordered pair. It's y before x, okay? All right, now look at your corresponding x values. What are you doing to 0 to get to 12? Well, you're adding 12. I'm going to have to go back and look at something. So here the slope is 1/2. Okay, so let me go back and look at something because obviously I missed something. Okay, I'm going to go back and look at these other 2 points, guys. Because I missed something somewhere. I can't get 1/2 and -1/2. All right, so I did these 2. So to get from -4 to -2, I got to add 2. Okay, I put -2. My fault. Let me go back. So much better. So your slope is +1/2. And if you caught that in the video before I caught it myself, I apologize. But I'll try to tell you before even the video begins that I made a mistake. So this is going upward from left to right. Again, to get from -4 plus 2 equals -2. And you all probably caught that before I did it. Sorry. All right, here, this is still -4 plus 4 equals 0. So you still would have gotten a 4, but instead of a -2, you've gotten a +2 as far as the change in y. Like I said, it doesn't matter what 2 points you choose. You're going to end up with the same slope, but you got to simplify, okay? Now let's take a look at B. B, I'm going to pick 2 points, and let's see. Let's pick this one and that one. Doesn't matter. Somebody may be picking 2 different points. All of you won't pick the same 2 points to find the change in y over the change in x. So what am I doing to get from 7 to 1? I'm subtracting 6. So I'm going to put -6. And then look at your corresponding y values. What are you doing? My x values. What are you doing in -5 to get to 5? Well, you're going up 10. -5 plus 10 equals 5. So this is going to end up being -6/10, but I'm going to simplify. I can divide them both by 2. That would give me -3/5 for the slope. And this is the one that will be going down from left to right. All right, I'm going to go back and just show you using 2 more points, okay? And some people hate dealing with negatives. If you don't like dealing with any negative coordinates, then don't. You don't have to. Okay, I'm going to do this one in green, and I'm going to pick these 2. I'm not going to pick anything that has a negative in it, okay? For some people that don't like dealing with it. So 4, let me do it in red. 4 minus 3 is 1. So I know the change in y is -3. And the change in x was 0 plus 5 is 5. That's how I get to 5. It's 5. So the slope is -3/5. And it's already simplified. All right, pause the video and try C on your own. Let me see what I had in here for you. All right, this is what you should have for C, finding the slope for C. I don't care what 2 points you choose. I'm just going to go with the first 2. So I'm going to calculate the change in y over the change in x, or what we call rise over run, guys. It's the same thing. Because the y-axis rises, you know, it's like an elevator. You can rise up, or I know it sounds weird, but rise down, which means a positive or a negative rise. And then your x runs, your x-axis runs. So that's why it's on the bottom. It's always rise over run. You got to rise before you run. If I asked you to run right now while you're sitting down, you couldn't do it. You got to stand up first. All right, so make sure you do y before x. So -6 plus 6 gives us 0. And -3 plus 3 also gives us 0. So here, I'm going to simplify. 6 divided by 3 is a whole number. Your slope is 2, or 2 over 1. I prefer just to write 2. All right, let's take a look at D. D's a little different, guys. Let's look at these 2. I don't want to use that highlighter, please. Let's look at these 2. So what do you do to 1 to get to 2? Well, you just 1 plus 1. You go up 1. So here the change in y equals 1. Now let's calculate the change in x. Well, what do you do to 2 to get to 2? Well, you add nothing, or you add 0. So the change in x is 0. But you can't take any number and divide it by 0. So 1 divided by 0 is what we call undefined, or any number divided by 0 is undefined, okay? So my slope is undefined. So my graph, if I were to take 2, 1 and graph it, 2, 2, 2, 3, 2, 5, and 2, 8, my graph would be some line that's straight up and down, okay? But keep in mind, you might be able to see something. Y'all see all these X values right here? Look at all the X values. All of them are the same. 2, 2, 2, 2. When all your X values are the same, there will be no change in them. And since X is on the bottom and there's no change, you'll always get a 0. And you can't divide a number by 0. So whenever all your X's are the same, they have the same coordinate, your slope is always going to be undefined because there's no change in your X's. And we know our X is the bottom number. Our change in X is the bottom number. Okay, now look at E. All my Y's are the same, so there's no change in the Y's. So since there's no change in the Y's, I'm guessing that the top number is going to be 0 because there's 0 change in the Y's. But you can see here, 1 plus 0 equals 1. There's no change in them. But to get from 0 to 1, I got to add 1. Well, now the 0 is on the top, and 0 divided by any number is still 0. So when all your Y's are the same, or in other words, there's no change in your Y value, your slope is 0, which means if you were to graph 0, 1, 1, 1, 2, 1, 4, 1, 5, 1 on a graph, your graph would be some flat line or horizontal line is what we call it. We call this one horizontal. And this one is vertical, okay? No change in the Y's, your top number is 0. So you're always going to get 0 for the slope. No change in your X's, your bottom number, your denominator is going to be 0. And we know we can't divide anything by 0. I can't tell 10 people to go get into groups of 0 because y'all going to look at me crazy. Miss Blue, how do I make a group of 0? I can make a group of 1, a group of 2, a group of 5, a group of 10, but I can't make a group of 0, Miss Blue. Something's wrong with you. All right, let's take a look at F. The table shows the distance a plane travels in hours. So I got distance in hours. The distance depends on the number of hours. Time has to go by before I can go anywhere, okay? If no time passes, I can't travel. So this is my independent and this is my dependent. The distance depends on the hours. You gotta have some time go by before you can go anywhere, okay? It says, what is the rate of change or the slope? So I'm going to calculate the change of Y over the change of X. I'm just going to choose 2 ordered pairs. So let's do this one and that one, okay? What do I do to 150 to get to 300? Well, add another 150. So the change in Y is 150. All right, what are you doing to 2 to get to 4? Well, you add 2. 2 plus 2 is 4. Now, 150 will divide evenly by 2, so the slope here is 75. Now, 75, what in the world does that mean? Since it's a real-life problem, you need to put meaning to it. So let's take a look at what Y represents. On the top, Y represents kilometers. And what does X represent on the bottom? It represents hours. So this is 75 kilometers per hour. You just look at what Y represents. Since you have the change in Y is kilometers, your distance. The change in X is the unit hours. So when you get ready to find your slope or write it, you just make sure you put kilometers per, you're going to put the top number first. Or the top unit first. The top unit is kilometers. And then per the bottom unit, which is hours. Some kilometers per hour. In this case, it's 75 kilometers per hour. That's the slope. Okay? That's the constant rate of change. That plane is constantly going 75 miles per hour. Now, I'll tell you, in the real world, a plane might do that. It might have to slow down because of turbulence, but it might not, okay? But in this case, it's saying it's going 75 miles per hour. It's probably on average. Now, when you're driving a car, okay, going 75 miles an hour, I'm telling you, you're not going to do that all the time, too, because you got to go stop at a red light. You have to slow down because a car might get in front of you. So, but on average, we use that to represent the on average speed, okay? What are you doing? Like, how many miles are you going on average per hour? G, the table represents the rate of change in which 2 machines are bottling milk in gallons per second. So I know, again, time has to go by before you can bottle anything. You can't say a machine is going to put milk in a bottle without time going by. So time is going to be my X. It's calling it S, guys. But the gallons is going to be no, it's not calling it S. S stands for seconds. Now, I'll be honest. I copied and pasted this, but normally we don't put S for seconds, guys. We put SEC. Okay? I'm gonna put SEC. And the unit for the amount of milk is in terms of gallons. That's going to be my Y. So I know I have change in Y over change in X. Then Y refers to gallons. And X refers to seconds. So my slope is going to be some amount of gallons per second. Just finding the slope is going to help me to see how many gallons per second this machine is bottling milk. And it's not two machines. It's only one. Okay, so I'm fixing it up a little bit. All right, so let's just pick 2 ordered pairs. So let's go with, I don't know, let me highlight it. Thought I had my highlighter 2 and 1.2 as 1, and we'll do the other one as 3 and 1.8. So I'm going to take a look at your Y's first. What are you doing to get from 1.2 to 1.8? Well, you're adding 0.6. So the change in Y is 0.6. And then the change in X is just 1. So the slope is 0.6, or the machine is bottling 0.6 of a gallon of milk per second. So a little over half a gallon of milk is going in a bottle per second, okay? All right. I am not going to calculate slope from a graph right now. I'm going to save that for tomorrow, and I'm pretty sure you all are happy about that because this video has been long enough. All right, guys. Thank you.